Problem 36 looks at groups that you might find on a chiral center, and you need to rank them in priority so that you can assign R versus S. So this question is just about how would you rank these groups. These four groups were on the chiral center. So for A, we have an H, a CH3, an OH, and an OCH3. So you might have a carbon with these four groups. They're all different, and so that carbon would be a chiral center. And then if you want to determine R or S, you have to rank these. So the low priority group would be hydrogen. It's got the lowest, the smallest atomic mass. The two oxygens would be the highest priorities. They have the highest atomic mass. So that means that the carbon would be 3. Now, which of these, this one or this one, will be priority 1? Well, you look at what's on that oxygen. Here we have an H. Here we have a carbon. Well, carbon beats hydrogen. It's a higher atomic mass, so this will be 1, and this will be 2. Let's try problem B. We have a bromine, a chlorine, a CH3, and a CH2 with a bromine. Well, the highest atomic mass will be the bromine. The next will be the chlorine. And then we have carbon versus carbon. Now, what are the three things that are on this carbon? H, H, H. And this one has bromine, H, H. Well, the first round of comparison, bromine beats hydrogen. So that's it. This will be, of these two, these last two were 3 and 4. This will be the higher of the two. That will be 3, and this will be 4. Okay, let's try problem C, where we have C, H, CH2, CH with 2 CH3s. We have a C with 3 methyl groups. And we have a C with 2 hydrogens and a methyl. So what you first see is that we're comparing 4 groups that start with carbons. Now, what are on these carbons? On this one, we have 3 carbons attached to it. What do we have on this one? We have a carbon is the best, and then 2 hydrogens. Here we have carbon, carbon, and hydrogen on that. And if you remember with double bonds, we have 2 bonds to carbon through that double bond, and then a hydrogen. So, if you compare these, the 3 groups on that first carbon, they all have carbon. And the next round, this has a carbon, this has a carbon, this has a carbon, this has a hydrogen now. So that is going to be the lowest priority. Then when we compare the third atom, there's a hydrogen, and a carbon. So that one wins. That's priority group 2. Okay, now we have 2 groups that are still tied. So what we need to do is go to the next carbon. There's a carbon there, and we can follow either path here. It's pretty symmetrical. So I'll go up here. Oops. Carbon right there. So what does this one have on it? It has 3 H's. This is the weird thing with double bonds. That carbon has 3 bonds on it. Normally we don't look backwards, but when it's at the end of a double bond like that, we have to. So the bond back through the pi bond to the other carbon is 1, and then there's 2 H's. And the first round of comparison, carbon beats hydrogen, and that's it. So this will be 2, and this will be priority group 3.